Hey everyone, welcome back to Math with Vanch. My name is Vanch and I'll be teaching you math, obviously. So in the last video we looked at implicit differentiation, and in this video we'll be looking at the derivative of inverse functions. So if you're ready, I am too. Let's get started. Okay, so let's start with figuring out what an inverse function actually is. Now this is just some review from pre-calc, but just to be safe, we're going to go over it, right? So an inverse function, for example, suppose we had the function f of x, and we can set that equal to anything. So we'll say x squared for now. So an inverse function is basically, instead of f of x, we can write y, right? So we can write y equals x squared. And then an inverse function is what happens when you switch the x and y and then solve for y. So for example, in this case, we're going to switch the x and the y. So we're going to make this x equals y squared. And then we're going to solve for y. So we're going to take the square root of both sides. So we'll get y equals root x. So these two functions are inverses of each other, right? So we can call this function f of x, and we can call this a separate function g of x. And the way that we denote inverse functions are by putting a little -1 sign on the top of the f of x sign. So if we had the inverse of f of x, to denote that, we would have f and then -1 of x, something like that. Okay, so another property of inverse functions is that if you have a composite function with f of x and its inverse, so for example, if you had f of f inverse x, that just equals x, right? Something like that. And we can show this actually by showing the exact same example that we did earlier. For example, we know that with the example earlier, we had f of x equals x squared, and f inverse x equals root x. So in this case, if we put that into here, we would have f of f inverse x, and our f of x is x squared, and our f inverse x is root x. So basically, instead of x, we're going to have root x. So we're going to have root x and squared, and that's just x, right? So this is another property of inverse functions. Just remember that whenever you have a composite function with two inverse functions, the result of that is always just going to be x. Okay, so with that being said, that was just a little bit of pre-calc review with inverse functions. So let's get into the calculus of it, right? So what if we wanted to find the derivative of an inverse function? So we can start with the exact same equation. We can start with the equation f of inverse x of the inverse function is equal to x, right? And what we want to do is we want to find the derivative of the inverse function, right? So what we can do is we can take the derivative of both sides. So, and this is just a composite chain rule problem, right? So this turns into f prime of f inverse x, and then multiplied by the derivative of the inside function. Now the inside function is just the inverse function, right? So we're going to multiply this by the derivative of the inverse function. So we're going to have d over dx of our inverse function. And then we're going to have the derivative of x, which is just 1. Right? So this thing is what we want to solve for, right? The derivative of the inverse function. So to solve for that, we can just divide both sides by this thing right here. So when we do that, what we'll be left with is the derivative of the inverse function is equal to 1 over f prime of the inverse function. And that's the equation right there. Now it's actually a pretty simple equation if you think about it. It's just the derivative of the inverse function is just 1 over the derivative of the regular function at this point right there. So let's look at how we can actually apply this equation in a word problem, suppose that we get on the AP exam. Okay, so we have the function f of x equals 1/2 x cubed plus 3x minus 4, okay? And we're also given that another function h of x is going to be the inverse function of f of x, okay? And another thing that we're given is that f of -2 equals -14. Now what we want to find is what is going to be the derivative of h of x at -14. So what's that going to be? So another property of inverse functions that we have is when we have a point on the function of the regular function, then for inverse functions we're going to have the same point except just swapped, right? So what that means is that if f of -2 is -14, then the inverse function of -14 is going to be -2. And we know that the inverse function is just denoted as h of x, right? So h of -14 is just going to be equal to -2. So we can use that to our advantage, because then we can use the equation that the inverse equation that we found earlier to find h prime of -14. So this is just going to be equal to 1 over f prime of h of -14, right? And we know what h of -14 is. That's just going to be -2. So this is going to be equal to 1 over f prime of -2. So now all we got to do is find the derivative of f. So we can just do, this is just a simple power rule problem. So the derivative of f of x, we're going to drop 3. So we're going to have 3 halves. Subtract 1 from the exponent. So 3 halves x squared. And then plus 3. Right? That's going to be our f prime of x. Now we can, to find f prime of -2, we can just plug in -2 wherever we see x. So 3 halves times -2 squared plus 3, which equals -2 squared is just 4. So 3 halves times 4 plus 3. 3 halves times 4 is just going to be 6, and then plus 3 is going to be 9. So f prime of -2 equals 9. So now we can plug this in right here to find that this is going to just be 1 over 9. Right? Not too bad. For these type of problems, honestly, you just got to know different properties of inverse functions, such as being able to switch the coordinates when we have inverse functions and just knowing these different properties. That's really the main thing when working with inverse functions. So that's going to be all for this video. All we did was just looked at inverse functions and their derivatives and how the formula can be useful in any type of AP problems that you might encounter on the AP exam. As always, if you have any feedback, please let me know in the comments, or otherwise, I will see you for the next video. Bye-bye.